You are probably looking through some right now. A window, a screen, a pair of glasses. It is hard as rock. It can shatter into pieces, and it is made from nothing but melted sand. And yet, if you ask a physicist one simple question, is glass a solid or a liquid, you will not get a simple answer. Because glass is one of the strangest materials in your entire house. It has the insides of a liquid and the surface of a solid. There is even a famous story that the old glass in cathedral windows is thicker at the bottom because, over the centuries, the glass slowly oozed downward like cold honey. Is that actually true? Let me show you what glass really is. To understand why glass is so strange, you first have to understand what a normal solid is, down at the level of its atoms. Take something like table salt, or a metal spoon, or a piece of quartz crystal. If you could shrink down and look inside, you would see something beautiful and orderly. The atoms are stacked in neat, repeating rows, like oranges in a crate or bricks in a wall. Every atom has its assigned place in a perfect, repeating pattern that goes on in every direction. We call that a crystal. And that orderly stacking is what makes a normal solid solid. The atoms are locked into their grid and cannot go anywhere. This is what happens when water freezes into ice. The water molecules, which were tumbling around freely, suddenly snap into a tidy crystal pattern. That is what freezing is. It is atoms getting organized. Now picture the opposite, a liquid. In a liquid, the atoms are not stacked in any neat pattern at all. They are jumbled, crowded together but disordered, like a packed dance floor where everyone is shoulder to shoulder but still shuffling and sliding past each other. That disorder and that freedom to move is what lets a liquid flow and pour and take the shape of its container. So there you have the two normal states. A solid is ordered and rigid. A liquid is jumbled and flowing. And here is where glass refuses to behave. Glass has the jumbled, disordered arrangement of a liquid. Its atoms are a frozen mess with no neat rows, no repeating pattern, no crystal at all. But unlike a liquid, those atoms are locked in place. They cannot flow. They cannot slide past each other. So glass is rigid like a solid, but on the inside, it has the chaotic structure of a liquid. It is, quite literally, a liquid that has been frozen solid without ever getting organized. Take a snapshot of a liquid in mid-shuffle, freeze every atom exactly where it sits, jumbled and all, and that is glass. So how does that even happen? How do you freeze a liquid without letting its atoms line up into a crystal? The answer is speed. You cool it too fast. Glass starts as sand, which is mostly silica, the same stuff as quartz. You heat that sand in a furnace to around 1700 degrees until it melts into a thick, glowing, honey-like liquid. Now, if you cooled that molten silica down slowly, the atoms would have time to find their places and snap into an orderly crystal, just like water turning to ice. But molten glass is extraordinarily thick and sticky, and if you cool it quickly, the atoms simply run out of time. They get more and more sluggish. The liquid gets thicker and thicker until the atoms can barely move at all, and then they just stop, stuck wherever they happen to be. They never got organized. They froze mid-jumble. Scientists call this moment the glass transition, and it is not a sharp freezing point like water has. It is a gradual stiffening, the liquid getting thicker and thicker until it is effectively solid. That is why glass does not have a clean melting point either. Heat it back up, and it does not suddenly turn to liquid, it just slowly softens, which is exactly why a glassblower can shape it. If your everyday window is starting to look a little more mysterious, hit subscribe, because now we can finally settle that famous story about the cathedral windows. You have almost certainly heard it. Someone points at the wavy, uneven glass in a centuries-old church window, notices it is thicker at the bottom, and says, "See? Glass is really a slow liquid, and over hundreds of years it has flowed downward." It sounds completely believable, especially now that you know glass has a liquid structure inside. But it is a myth. Here is the truth. Glass at room temperature does not flow. Not over 100 years, not over 1,000, not over the entire age of the universe. The atoms are locked so firmly that the amount they would move in all that time is far too small to ever see. If you actually do the math, for a window to visibly sag from flowing, you would have to wait many times longer than the universe has existed. So, why are those old windows thicker at the bottom? Because of how they were made. Centuries ago, glassmakers spun molten glass into flat discs, and those discs came out naturally uneven, thicker near the edges. When the glaziers cut them into panes and set them in the windows, they simply tended to put the heavier, thicker edge at the bottom, because it was more stable that way. It was a choice made by a craftsman's hands, not by gravity over centuries. So glass really is a solid. A strange one, but a solid. Now, two quick mysteries that this strange structure solves beautifully. First, why on earth can you see through it? Think about how odd that is. Glass is made from sand, which is completely opaque, and it is hard as a rock. Yet light sails right through it as if it were not there. The answer comes from those locked-in atoms. In glass, the electrons are held so tightly and so evenly that a particle of ordinary visible light simply does not carry enough energy to be absorbed by them. The light has nothing to grab onto, so it passes straight through without being stopped. But here is the lovely proof of this. Ultraviolet light, the kind that gives you a sunburn, carries more energy, and that energy is enough for the glass to absorb. So visible light goes through, but ultraviolet gets stopped. And that is exactly why you cannot get a suntan sitting behind a closed window, even in bright sunlight. The glass is invisible to your eyes, but a solid wall to the rays that would tan your skin. Second, why does glass shatter so violently instead of bending or denting like metal? Again, the answer is in the jumble. In a metal, the atoms are in those neat rows, and rows can slip and slide over one another, which lets metal bend, dent, and deform without breaking. But glass has no neat rows to slip. Its atoms are locked in a rigid, disordered web with no way to gently give. So when you push it too far, it cannot bend even a little. Instead, a tiny crack finds a weak point and tears straight through the whole web in an instant. That is why glass does not bend, it breaks, and why it breaks so suddenly and so completely. So let's answer the question we started with. Is glass a solid or a liquid? The honest, wonderful answer is that it is a solid that never stopped being a liquid on the inside. It has the frozen, jumbled structure of a liquid caught in the very act of freezing, locked so firmly in place that it stands rigid for thousands of years and lets the light pour through. It is a moment of molten chaos, paused forever, sitting quietly in your window frame. The next time you look through a pane of glass, remember that you are looking through a liquid that was frozen mid-motion, holding perfectly still since the day it was made. Subscribe, and next I will show you why your metal spoon feels colder than your wooden table even when they are exactly the same temperature. Because that one fools everybody. The ordinary world is hiding the best physics of all.